Hi guys, so last lesson of my invention project, I need to get this thing finished because currently I've moved the saw I was using and I now have no way of filming these videos that's very appropriate and it's getting a bit difficult. I'm balancing the camera all over the place. So I'm working on the jaws today and getting the jaws made. We're going to look at some workshop machinery that will come up in exams, questions of appropriate use, how they work and key features, and you'll have revision cards that appear on the screen. And then I'm just going to quickly look at the use of dowel jointing to make these pieces go together. So we're looking at this jaw part at the top for finishing off our problem solving and mechanism based project. Let's go. Cheers. So before I start cutting, of course, I've got to mark out. I've marked out by making a template out of cardboard. The template is 30mm wide along here, and then I've used a circle template to make a perfect radius there. And it comes around for the grabber here. Now I'm going to move over to the coping saw and start cutting that out. The material I've used is birch ply. Now I've used birch ply for these because they need to be very consistent. Plywood is very consistent, it's a man-made material. So as a manufactured board, you can see there's these layers, multiple layers, and birch ply is more expensive, but it is very dense and very solid. So I can work with it and I can get a really high level of tolerance as the thickness is perfectly uniform all the way through, and I'm not really going to get any tear through, rip or splitting as I would with hardwood on these ends here. On these ends I'd have to be very conscious of the grain when I cut those, because if the grain was running in this direction, that section would snap off completely. If the grain was running in this direction, this top section could snap off completely. So a manufactured board like plywood really is the best choice for this part of the design. So this machine is called my scroll saw. Often in school these are referred to as a Hegner saw, which is just a brand. If you've got a red one in your classroom that says Hegner on it, that's a Hegner saw. But it's just a power scroll saw or fret saw. Very similar to a coping saw, which I'll show you a photo of in a second, but an electrical version. So if you think about the mechanism and how the mechanism works, it's a reciprocating blade. So the blade moves up and down in a reciprocating sawing action like this. And on this particular machine, you can alter the speed. Now, I've fitted mine with a very fine 1mm piercing saw blade, because I like to be able to cut very accurate things on here, because I have other machines that can be used for larger scale work. So this machine here is called a bandsaw. Now, it gets that name because internally, it has one continuous blade, which is a band shape. So it comes from the base, round here, curves around, all the way up, one large blade, around and goes down. So with a bandsaw, you get a continuous, straight downwards cut, because it's a rotary movement inside, around a pulley up here, and a pulley down here. Now that's got a much thicker blade on, and I generally use that for cutting down pieces ready to go onto the lathe or rough shaping materials and a lot of ripping long straight cuts along the grain. So as you saw in the video, I have marked out and then cut these pieces. There are 4 of them. I'm now going to move over to the disc sander to shape them, and I might do some filing on some of the areas that you can't get into on a disc sander. On a disc sander, it's very important to not work too close to the wheel when you're at school, to keep a safe distance, and that will be advised by your teacher. if you're experienced in using it, you can work fairly close, but it's advisable to wear gloves. Other PPE includes goggles and a dust mask if you don't have suitable extraction. But as you'll see, I've got extraction running on my disc sander. Now this machine here is a disc sander. Now, those of you that know a lot about machines will know that this actually is a lathe. This is the same lathe featured in one of my other videos, but I've converted it to attach to the facing plate a disc with a 120 grit piece of abrasive paper on. Now, within school, you will have a machine that looks quite different from this in some ways. You will have a bed that runs flat along the centre of the machine, but in most schools, half of that bed, this side, will be blocked off. That is because your workpiece, if it's pushed up by one side, it will force the work into the air. So this machine runs counterclockwise. So anything I push into this area will be pushed down, keeping it nice and safe and secure. Anything on this side, the force will push it up. So we've got another rotary system there. So generally we work from the centre outwards, but if you're experienced, you can work on the other side, but you have to remember to keep your work very secure when you do so. So I've cut them all. I'm now going to go ahead and put 2 dowel joints through. One for the articulation point, so along the base point here on each one, and then one running between each 2 pieces to keep them nice and strong like the model. I'm going to use a 6mm dowel, so I'm actually going to drill through with a 5.5mm drill bit in exactly the same way I've done in previous videos, where I mark the centre, drill a pilot hole, and then go through with a 6mm. So I'm pretty much there with this device. It solves the problem really well. It holds the phone. Now I was considering fitting a torsion spring in here to make these jaws grab closed. But actually the way in which I've designed them, and because it's always going to be hanging, that section, because I'm trying to film things that I'm above of, when I insert the phone, he says, it doesn't fall out, a lot of faith in this, the phone's held in really securely anyway. So the phone holds in like that. And can be positioned really well. So I can angle it. I've left this one quite loose down here so that I can attach this to the wall. I'm having trouble getting the magnets, so for now I may screw it on and make a different section so that the same thread can be put into a vise, into the wall, in different places. So I can have it wall mounted like that and film above me. And I can also have it desk mounted, and this long arm comes out, and if I lock up the wing nut, it holds the weight really well over what I'm doing. So I'm generally really pleased with that. I think the project's gone well. I hope you've learned some stuff about machines, about safety, and about problem solving throughout this, and it will help you with your NEA coursework, Key Stage 3 work, developing any project ideas really, and just learning how to design and make stuff. Cheers!